Hey there, I'm Jadrian, and in this video I'm going to talk about speed time graph. So let's get started. So before we get to speed and time, I just want to talk a little bit about this graph. So a graph like this, we have dv and iv, okay? So the dv stands for dependent variable, okay? Dependent variable. Okay, so the short form will be dv right here. So for the iv, it stands for independent variable. So dependent means you depend on something, right? Something depends on another thing. And the independent means you are independent. No one could control you. So in this video today, we are going to talk about speed time graph. So speed and time. So the time here is going to be IV, which is independent. So the reason time is independent is because you can't slow down time or you can't speed up the time. Time is constant, okay? And for the speed here, you can control the speed. You can increase speed or you can decrease speed, okay? So this is going to be dv. So the iv is always in the x-axis and the dv is always in the y-axis, okay? So x and y. So right here, the time is independent, right? Which means it's in the x-axis, so time. If time is in the x-axis, in this case, the speed is going to be the y-axis, okay? Let me just move this down a little bit. So what is the relationship between speed and time? We know that the formula is speed equals to distance over time, which means if you increase in speed, you must increase in distance as well. Which means more speed means more distance traveled in lesser time, okay? So let me draw a table first. So this is going to be our speed and this is going to be our time, okay? So in this speed, we are going to put in the m. And the time we're going to put as second. So I'm going to add up a lot of lines here. Okay, so let me just start with 1, 2, 3, and 4, and 1, 2, 3, and 4. So to make it less complicated, I'm just going to use 1, 2, 3, 4. So right now I'm going to add in all the scale, which means the number line 1, 2, 3, 4, 5, and 6. So right here, I will do the same. And by the way, this 0, 0, this point 0, 0, we call it as origin. Okay? And the way we read a coordinate, which is start with x and y. So right now I'm going to plot it all of these coordinates into this graph, and the speed is going to be 1, so this is going to be 1 and 1, 1, 1. Okay, and let me just use blue pen. Okay, I'm going to use blue pen 1, 1, which is cut, then 2, 2, cut, 3 and 3, then this 4 is going to be like this, okay? Okay, so the characteristics of this speed time graph, if we have the speed and we have the time, we will find the distance, right? So right here, we can do it out. We can find the distance at this point, which is the speed. Speed is 1 equals distance over time. So it's going to be 1 as well. So right here is going to be 1 meter, okay? This is going to be 1 meter and this is going to be 4 meter. Speed equals distance of time. If this 2 times 2, which is d, okay? So this is going to be our 2 meters, and this 9 meters, and 4, 4, 16 meters. You just have to put it into the formula and you will find it, the distance. And right now, this table represents a car, okay? A car. So this car, we have to, if we want to find the total distance traveled by this car, the total distance traveled by the car, it's the area under this line, this graph. Okay, I'm just going to put it like this. So area under this line, this graph, it's equals to the total distance traveled by the car. So speed time graph. Okay, the characteristics, it is that area under the line is equals to total distance traveled. So if you want to find the total distance traveled by this car, this table represents a car, right? Which means that we have to find the area. So the area is 1 over 2, because this is a triangle, so 1 over 2 times base times height. And 1 over 2 times the base, which is 4. Then the height here, it's 4 units. So it's going to be 4 as well. So 1 over 2 times 16, because 4 times 4 is 16. And if 16 over 2 is going to be 8 meters. So this is going to be meter and this is going to be second. Okay, the total distance traveled by the car from time 0 to time 4 seconds, it's 8 meters. Okay. So I'm just going to erase this. And right now I want to talk about the acceleration. So notice this gradient, right? This gradient, which means every time, every second, the speed is increasing, right? So if the speed it is increasing, which means it is accelerating. And if the speed, like this line right here, so the speed it is decreasing, which means it is decelerating. Okay, acceleration and deceleration. Okay, so gradient of this straight line graph, it is going to be the acceleration. And by the way, both of these rules only apply in this speed time graph. You cannot apply both of these rules in the distance time graph. And if you do not know what's a distance time graph, I had previously made a distance time graph video, and I recommend you watch that video first. So the formula of acceleration is going to be A equals to V, which is the final speed minus the initial speed over the time. Okay, so if you want to find change of something, it is always maximum minus the minimum. Okay, which means the final minus initial. So let me just erase this first. So right now I want to find the acceleration of this time 0 to time 4, which is equals to the final speed is going to be 4. The initial speed is going to be 0, which is here. So 0, and the time, which is the 4. So minus 0, which is 1. Okay, so just now I had mentioned that the gradient is equals to acceleration, which is the gradient is y2 minus y1 and x2 minus x1, right? Which is change in y coordinate and change in x. So in this case, actually it is the same. The formula for acceleration, it is basically change in velocity and change in time. Okay, so basically they are the same. The formula that I had first written it down, it is the same as this one. So 4 minus 0, it's 4, and here 4 minus 0, it is 4. So 4 over 4 is going to be 1, and here 1 ms squared. The reason the SI unit for acceleration it is ms squared, it is because the SI unit, the unit for velocity, is going to be ms minus ms, which is change in speed, and over s. So after I have minus this, I will left ms and s, which is ms over s, right? So this denominator s, I'm just going to bring it up here, and I will get ms squared, which is same as this guy, ms squared, like this. Okay, So I've talked about this acceleration. So right now I'm going to show you the acceleration right here. So the acceleration is going to be 1 ms squared, right? Which means every second, like here, every second, like 1 to 2. So this 2 second right here, notice that your speed had increased by 1. Okay, so when you go to 3, your speed is going to increase by 3. So slowly you are getting faster and faster, and until you reach here. Okay, so 1 ms squared. That's it for this video, and remember that both of these rules only apply in speed time graph, not in distance time graph. And I will see you in the next one. Bye.